It's Roger once again, and coming to you with a new discovery from National Geographic reporting on it. A new human organ hiding in plain sight. And Mudfossil University has been doing research on soft tissue fossils that have been DNA certified, and I'll be showing all this stuff. And we have seen this for quite some time. Now, what it is it looks like a mesh. The interstitium is a layer of fluid-filled compartments strung together in a web of collagen and flexible protein called elastin. Previously, scientists thought the layer was simply dense connective tissue. Now, I'm going to show you what it is, and I'm going to show it in pretty good detail. I believe what I'm showing is accurate. You make the decision. Okay, this is the structure that they're talking about. If you took a layer of skin and put it over the top of that, and directly below it was that matrix in a fluid-filled, bloody sort of mesh, that is what they're talking about. And below that you have your basement layer, basically. Now this is on this very thin skin. It has these really fine fibers. Now I'm going to show you what happens on the other skin. Okay, we find these all over too, these tendon balls with the little tiny straps. They go into the bones and the ligaments, and I have some here that show the holes that they go into. This is a mud fossil right here, and those are the holes. You see, and it's how well articulated this is. That's the ligament, and inside the ligament you see those little tiny holes. That's where those balls go. And this has all of the fascia, and if you can see this, you see this strap coming here that comes across in a triangle. They all have a bone wrap, and the ancients used to call it tunica. Anyway, this is very, very serious, and it's well proven, and these things are easily seen and easily checked. And that is what happens on the inside. There is no bones to speak of. That's the last little spicule of bone that's left in that one. And they continue to transition over the course of time. Alright, so you know this type is the stone ball type that invest in, and I'm going to show you and this has the little straps on it, and it also is in the skin. It's a very, very similar thing, and they just never picked it up in the skin before. Alright, the takeaway here is that these are the tendons, and the way they, you see, this is the tendon, and this is the way they develop into mineralize, and some of them actually have claws like that, and those are the ones that are in the grip skin, I believe, and I'll show you that. This is the type of tendon the type of tendon ball that sticks into the grip skin and the toes, you know, the stuff that grabs and grips hard, like your fingertips and your toes and so forth. Now that is coming up like this. These are spikes, and it would have dug in here. This flesh has eroded away. Now I have another one over here that shows this, but not quite with the spikes. Hold on a second. Here it is right here. Alright, now this one here shows that tendon ball, but you can't see the spikes, but you can see the ball clearly. You see this ball here? That's the tendon ball. That's the stalk that it ran up on, and that is the strap that evaporated away. This has been combusted in a manner one way or another. I think I know how, but I won't talk about that now. This is the tendon ball, and that is one as well. The stalk came up through here, and it is eroded away with that red bloody material that surrounds it, which I showed in the anatomical drawing a moment ago. Okay, so you understand this is very real research. This was done several years ago, and there was 3 samples sent in, and the tests are on Mudfossils.com, and way over to the left you have to scroll to the bottom, but the results were that they came back as human mitochondrial DNA. And see, it's Homo sapien mitochondrial cytochrome B gene, Homo sapien mitochondrial D loop region, and all 3 of them came back the same. And this was it was certified. It was certified results, so it's not something that was silly. So and it can't be just dismissed. It was done, and the specimens are here to be analyzed again. So this shows that it's pretty solid stuff. Now, we also had them CAT scanned by Jesse Grant and Associates, who CAT scans industrial equipment to see what the porosity is and what the material is inside, and you know, and deep, big, huge metal things. So he did 7 CAT scans for us. Fabulous, fabulous people and fabulous work. Easy to use, everything. It was absolutely wonderful. And then we had Gil Headley, who was an autopsy specialist. Well, he owns an autopsy school, actually, teaches worldwide, and he verified all the things that we're saying are also true. And the specimens that I'm making the claims about, he validates. So that's what it is. So it may help in the health, because these are specimens that are not just lookalikes. These are actually the anatomical specimens after the thing died, encapsulated in mud, preserved in a manner that now is understood, and I have recreated and done the same thing here. It's a process of wet removal of the volatiles, and then a slow mineralization in wet solutions, and then a drying out process into mineral or stone as everything oxidizes and just dries out. Now, and it's pretty well proven. So I want to contribute. I don't have any big desire for anything special out of this. I just want this to be known, and I've been trying to get it known for many years. Well, 6 years anyway. So I'm hoping it'll help. That's all. By the way, recently Harvard and Max Planck, who I did send all of our research to them several years back, really, but they now certify that DNA is in mud and dirt, and it's everywhere. Now, the mud is eroded away from the actual creature's body, which was the mud fossil. So they don't want to talk about mud fossils because it sort of has an implication that they don't like in academia. It throws a lot of water on the things that they've been saying, and this is the rub. So I need to get this out to the general people, and hopefully I've contacted the people that are making these claims. No one will contact me back. So I'm hoping this will break that ice, because it's so completely obvious now. This is a mud fossil brain, and look at the separation and the layering. Who would have ever suspected that? This is the brain, that's the esophagus, nasal cavities, and you can see up through the brain it's heading towards the crystal orientation. I'm pretty sure this is the actual brain fibers. They're well known and seen now in the latest PET scans and so forth. By the way, they should examine the Mitchell Hedges skull, because that is 100% authentic. I stake my reputation on it. You see these fibrils, these fibers, the neuron fibers that are in a regular brain? What do you see here? You see the identical same thing. This brain, this head was face forward, and it crushed his nose and his lip and his chin, and the brain drifted forward, left this clear spot, but you can see it would have been like this. All the fibers are going to all the correct places. The eye sockets, the optic nerve, the eye sockets are exactly correct, and they did light strobes through this with all the different electron spectrum, and all the lights lit up all inside there. Absolutely amazing. The eyes flash with just incredible intensity. And the reason is because these are fiber optic tubes, literally fiber optic tubes. And let me just show you one thing here. You see this over here? See that? If you look close, you're going to see, you see the little channels there? That is what happens to your brain. When your eye picks up that light, it conducts it down just like little fibers heading down into your brain. That's what the optic nerve is. We are sending these signals through us somehow with electricity or light or chemical energy reactions. There is some method to this madness. I mean, I can understand how this works because it's literally rattling electrons. But how it interprets it and seen as what it is in our mind, that there, woo. But I have all of these things are just, there's no question what they are. No question whatsoever what they are. And they are tested. This CAT scan, that, that's been DNA tested. There's other ones over here have been DNA tested. All right, so I suppose that's about it. All right, this is the one last thing, extremely important as far as health goes. These are the transition metals. These transition metals are in your blood, and they link with a very, very loose handshake. And the way they transport things through your body with that handshake. At a certain pH, they hold on to something. When they hit a lower pH, they drop it off. And at that point, something else attaches to that, and it brings it back up to the heart or lungs. It's a process of pH changes, very, very subtle pickup and delivery of nutrients and minerals and gases and all that stuff in your body. Now let me show you how I can say that I can prove that. All right, you see this heart? You see that's a cross-section of the heart. This is an opalized heart, and opals form in dense blood with a lot of those transition metals because they have those colors. Now, what can we take away from this? So, in other words, this is a heart, but it was originally a living heart, and now it has been invaded by these molecules that are the transition metals that have attached to these certain specific areas, specific molecules indicated by the specific color. Now, why is that important? That means that this tissue is a specific tissue because stability for this tissue requires this green metal. It could be copper, it could be vanadium, it could be whatever, and they are a mixture of them because they are complex chemistry. This is not just one little thing to say, give me a plus or a minus. There's a lot going on here. So, but the takeaway here is this tissue is so specific that it requires that molecule. It requires it here, over here, over here, and over here. So the takeaway from that is if this tissue does not have that molecule, it's not going to become stable. Because now this is stable. Hard as a rock. It's rock. It's opal. Now, so it found the thing that it wanted to become stable with. It didn't find that the first molecule that bumped into it. They continue to pick up and let go because they are the transition metals. Anytime there's aqueous solution, wet, bloody solution, with all these things in it, they will pick it up and let it go, pick it up and let it go, until it finds the guy that it really wants to be strongly attached to, and that happens to be this green thing. Now, what does that mean? That means that in your body, that specific tissue is so specific that if it was showing up yellow here, we would know the guy was sick. All right, there would be some kind of a tissue problem. They may be able to take in little fluoroscopes inside the body and look at the color, what the re-radiation. There's X-ray fluoroscopes. They can shine a light on something. It shines a light back, and they know what kind of chemistry is in the thing that they shine the light on. Now, I don't know if they can do that inside the human body, but if they could, they'd go in here, shine the light on there, and it says, well, there's no copper, there's no aluminum, there's no whatever it is. And then you got to do something to fix that. Now, the reason you're not going to have copper or aluminum or gold or whatever the transition metal is, and you need every single one of them, I don't care what anybody says, you need every single one of them, and there's almost 100, and you have uranium in your body too. So don't listen to anybody who says that's not true. Now, you need those to transfer molecules throughout your body. All right? So they're going to be floating all around your body, all of these metals, not in huge quantities, in very, very limited quantities, but they have to be there. And if they are not there, you are going to be sick, and you may die, or you will be chronically ill, because the metal that turned this thing blue is not there, and it's now yellow, and that means that you have a heart palpitation or whatever, or is there something not in your diet that is being brought into your system that is for your skin, let's say. Now you got itchy all the time, you got blisters. That is the transition metals job. How do you get the transition metals? You get the transition metals because enzymes make them. They are typical chemistry kits that float around. That's all it is. A little kit of chemistry goes around and says, okay, you over there, I'm going to break you down and make some gold out of you, or copper, or whatever. And it is specific for that element. Now, how do you get those enzymes? Those enzymes are created by bacteria that are in your gut. Right? Bacteria controls your life. I mean, I'm serious. And then when you take antibiotics and you kill that bacteria, and then your stomach reacts, and then you don't have the bacteria to do the mining and do the breakdowns and do all the things. So now that chemistry cannot be absorbed by your body, or it is absorbed in excessive quantities because the other thing that's supposed to limit it is not there. And then you end up with excessive things in your body, or not the things that you need in your body. All right, so I guess I got a little carried away, but that's the reason mud fossils are so important. There's so much to understand from here, because that's the damn thing that it was living at one time. I mean, that's all it is. It's people have to wake up to the fact that this is reality. So anyway, it's Roger. Hopefully somebody will contact me. I guess that just about wraps it up. All right, thank you so much, and congratulations on your discovery, and I hope I can help in any way I am willing. Okay, this will help to explain the situation here. I'm going to let this play. It's absolutely fabulous. It's from UKY Ortho, Strolling Under the Skin. Absolutely phenomenal. And I'm going to just let it play, and then I'm going to explain to you how this plays into this new discovery that they made, and how the mud fossil research plays into the whole thing. All right, so here it goes.
The story of this film began about 20 years ago. We were transferring vascularized turkey tendons in our university research lab, and were struck by the intricacy of the vascular network. Thereafter, the Chinese School of Plastic Surgery discovered the notion of the retrograde flap, and we began to develop a technique for transferring vascularized retrograde tendon flexor transfers onto the cubital pedicle to get around the problem of reconstructing flexor tendons. Little by little, this new vision of anatomy began to throw light on the relationships between the tendons, the sliding sheaths, and the vessels, and to challenge the very foundations of the classical school of thought.
All right, I just want to explain something. As they slide these vessels back and forth, it has a similar effect, and then shortly after you'll see the actual vascularization, which is the inside, just below your skin.
During the revascularization following the release of a garret, we observed that not only the tendinous extremities bled with an apparently circular longitudinal and peripheral vascularization, in contradiction with the avascular theory that held sway at that time, but that there seemed to be a real continuity between the sheaths and the tendons, which was not interrupted despite the distension occurring during sliding.
All right, here's the area.
It was also clear from observing the behavior of the vessels of the common carpal sheath during flexion and extension that rather simplistic mechanistic explanations could no longer account for these phenomena, and that this apparent disorder and irregularity of shapes was in fact the basis of some other form of complexity that we still knew hardly anything about. In our attempts to find an explanation, we began detailed in vivo microscopic analysis of the distribution and mobility of the vessels using 25-fold video magnification. By looking at a vessel as a petrol pump, we were able to approach the problem more simply. There was this vertical structure looking like the main part of the pump, then the pipe, and finally the adjoining vessel, just like a car filling up at the gas station. The pipe seemed to move.
Well, they go into it. Well, it's 28 minutes long. We're only in 2 minutes, so I don't want to go in forever here, but the point being is that the body is so intricate in the way it deals with things that it needs to deal with. These are the tendons here. These are the tendon straps that are in your body. They slide back and forth, and there's a bloody layer that surrounds them, and they're so strong. And when they change over, I mean, the mud fossil research is so deep on this body anatomy, because we have, I mean, I have them, they're literally identical to that. I can see that identical same structure in my mud fossils, and I can see where it integrates and where the abrupt transitions occur and where the muscle takes over, and the integration and the intricacy of the muscle tissue and how the blood vessels interact with it. And it's just very, I mean, it's the exact body. It's the body. It's just now hard. All right, this is the skin, and they're going to go through the regular thin skin, and then you're going to see the ridges of the fingerprints. They don't say that, but that's a totally different structure. Now watch.
Organ. It's a set of organs which is anatomically, physiologically, culturally, and psychically complex.
All right, that's your sort of skin around your
Of all the
arms and
senses,
so
touch is the most fundamental. You can survive without smelling, seeing, or tasting, but not without touching. The skin permanently relays information.
fingertip.
It never shuts down, blocks up, or sleeps. It has an odor, a texture. It perspires, secretes, eliminates. It exchanges signals with the outside world. Thanks to the skin, the body's surface is as much a machine for communication
Now look at that. Look
as
at
a
it.
protective barrier.
All right, this is the stuff that those little balls and straps allow. You see, that's it right there. Basically, this is what you're talking about inside. It's underneath, but you can see the above pattern of it.
It can change color, texture, and shape, and retains the
You
vestiges
see all
of
these little
aggression,
spots.
such as sunburn, scars, and disease. At birth, it is taught, ready for life. Then, little by little, it ages, gets wrinkled, folded, and sags. Whether in newborn babies, adolescents, or adults, the skin is never totally flat and smooth.
You see this? These, I believe, are where the balls are. Okay, and these are the little straps for them. And I mean, they run all over the place, but there's a pattern, and that allows you to do all of these different things. That's my take on it. It needs a little more work, and there's different areas of skin, and like on your wrist skin, it's extremely fine, and on your facial skin, it's extremely fine. And there are certain, they end up becoming certain clays, and I can see that quite well in the mud fossil research as well. All right, now watch this. In the body, obviously, they're a different mineralization, and they're more flexible, and they're more, gooey than they are when they harden up and mineralize. But watch this now.
Smoothly, and how can sliding come about?
Sliding of your skin. How does it do it?
When you look closer, you can see that just below the dermis and hypodermis, there's a highly mobile tissue encompassing everything else and penetrating what is known as the undermined plane. When this tissue is tracted upward, you get a surprise. Curious?
You can actually see the balls and the straps if you look carefully.
Movements occur due to the bursting of vacuoles at atmospheric pressure, demonstrating the existence of hydraulic systems under different levels of pressure.
You see it? Now, they're going to change, they're not going to be this color when they mineralize, but I believe that is the structure of them. Because that's what I see in the mud fossils we have.
The show is total with pseudogeometrically shaped fibrillar structures encompassing the muscles, skin, and fat. Yet what are these shapes? What do they do, and why are they there? Is this what we have traditionally termed the connective tissue? Let's now delve into this world of fibrils.
All right, she's fabulous. This thing is just stunning to watch. It really is, and it's 28 minutes long. So I'm going to leave it at this. You can see that what I am making, the claims I'm making, are not just silly, idle statements. They're based on everything that's factual. That's all I can say. All right, so it's Roger, just somebody get a hold of me if they're interested in any of this research, because I've got a lot of it, and it's kind of spectacular, and it's over the edge. I know you're going to be. This is why they've been avoiding me for so long, because it's a little more spectacular than it is unspectacular. It's not just your average monkey bone. This is serious, but this is not only spectacular and in a curious manner, it has a lot of ramifications on every single thing in every single person's life. And I don't care who you are, this touches you. So if anybody's interested, I've been interested. All right, thank you.